And so we're going to leave the cotangent, but we're going to switch this to sine over cosine. And this is another reason I choose this particular place to do it, because this is something very important. Whenever you switch tangents to sines and cosines, or even secant to 1 over cosine, so far it's always just been an x in that spot, correct? Nothing more than that for the angle spot. Well, this one has pi over 2 minus x, agreed? And whenever you switch it to its other forms, that angle has to stay. You can't just change it to an x all of a sudden, because I'm trying to find tangent of that angle. So I better find sine of that angle and cosine of that angle for it to work out properly. I can't just find sine and cosine of whatever angle I feel like, because there's no guarantee it'll be tangent of that other angle. Now here's where some of you that missed 7-3 day 1 are possibly going to struggle a little bit, but kind of rely on your classmates. On 7-3 day 1, we learned sines formula and cosines formula for sum and difference. These are called sum and difference because sometimes we add the angles and sometimes we subtract them. Sum and difference. Here we're subtracting. So all we're going to do is we're going to look back at sines formula. And sines formula says to take the sine of the first one, you might want to get out the notes if you have them with you, times cosine of the second one. How come I didn't put negative x in there? How come I just put x? That's because that subtraction that's in here gets dealt with next. And in sine, the sign stays the same. So minus. Now those that weren't here, try and logically go about this. What's probably going to come next? I took sine of the first one and cosine of the second one. Yeah, you're going to kind of flip it around. Exactly. You're going to take cosine of the first one and sine of the second one. Okay. So any questions on that, or any questions why it's not negative x in any of those or anything like that? Basically, that sign right there basically got transferred right to there. Yes, it matters the order a little bit because it is subtraction. Trust me, you'll find out in a little while that the order does make a difference. On the bottom, cosine had its own formula. It's that take cosine of the first one times cosine of the second one. And what happened with the sines in cosine? They flipped. And what does this one say in the middle? It says minus, and so I better say plus. And then sine of the first one and sine of the second one. So some people look at this and say, Mr. Bogusch, you just made it worse. And I did. I agree. I made it worse. But I made it to a point that we can solve. Because a lot of people forget right now that pi over 2 is synonymous with 90 degrees. Are some of those values up in blue values I know? They are. They're values I can get off the unit circle. Because pi over 2, again, what did you say it was? Is 90. And what's the ordered pair up there? 0, 1. 0 is which value again? Is the cosine, and 1 is the... So this value right here, sine of pi over 2, can I replace that? With 1, exactly. So it's 1 times cosine of x minus 0. Are you sure? Cosine of pi over 2, yes, 0 times sine of x. Okay, just hold on here, right? So cosine of pi over 2, has that changed in the last 2 seconds? Oh, it's still 0 times cosine. And then plus, well, sine of pi over 2 hasn't changed either. That's still 1. And the question was, doesn't some of that stuff just cancel off completely? And yes, it does. Anything that's 0 times anything is 0, meaning gone and gone. The question earlier was, could these be flip-flopped in their place? No, because then this would be minus if it was in the second half, so you can't flip-flop where they are when subtraction is involved. Okay, so be careful with that. So basically, what's left of my numerator? Cosine of just x, right? I got rid of the whole pi over 2 minus x, right? We did it legitimately. And on the bottom, I'm left with sine of x. And again, do you agree that I got rid of all that angle business legitimately? I didn't just cross it off and say it's an x. Oh, okay, so this equals cotangent of x. Why is that important? Oh, because that's what the left side has said this whole time. Could I have changed the left side and tried and made it look like the right side? You could have. Would have been tough, but you could have done that. So here is once again where it is going to be difficult to correct, because couldn't all of you have written that down before we did anything? Yep, you could have written it down. And that's kind of what happened. I'll be honest with you. When I looked at some of your homework, it's going along really good, and then bam, answer. Kind of like John Madden. It says, oh, bam. Any questions? Now, here's what I'd like you to do. Think back to the graphs, tangent and cotangent. Are they very, very similar? And if you could just take tangent's graph, reflect it over and move it over 90 degrees, would it be the same as the other graph? Well, let's take a look. This pi over 2 here, isn't it just a phase shift? And this -1 would have been put out sight to reflect it. So are these the same graph? Yes, they are. So truly, you should know, yes, those are the same. Because all it is shifted over and flipped. So it does work. Okay. What I've chosen to do for example 3 is give you a similar but non-tangent version of a verify problem. And I would like you to try that one right now. Use, I believe it's cosine in it. Let me see. Yep, cosine. Use cosine sum and difference formula and see what you can do.
Oh, it's on now. Okay. Okay. So we have to make this side equal. So we sine theta equals cosine of this. Don't mind me, I'm just rewriting it. Is you gonna have my shadow in the video? Okay, good. Oh, well, okay. Oh, yeah. And then cosine's little ruly thing is... I can so do this. Okay, so got sine of theta equals cosine of the first one times the cosine of the second one minus, because cosine it changes, sine of the first one, oh my, times sine of the second one. That? It's a times. Yeah. Okay, and why did I do what? Because that's this, the cosine's formula. Yeah. And 3 pi over 2 is 270, so you can change it to 6. Keep writing everything out. So cosine at 270 times cosine of theta, and then subtract sine at 270 times sine of theta, and cosine at 270 is 0, so it would be sine of theta is equal to 0 times cosine of theta minus, and sine at 270 is -1, times sine of theta. And then you would get sine theta equals 0 times cosine of theta minus -1 times sine of theta. And when you multiply 0 times anything, it would become 0, and -1 times sine would be negative sine, but since it's a negative, it would change it to sine theta equals sine theta.